pi r squared for the area of a circle and circumference. 2 pi r or pi times d, either will work. Very good. Those will be useful today. Thank you. Alright, we're getting into the portion of the book where some of it you'll need a calculator for, but some of it you will not. So I managed to synthesize out everything that you will need it for. So I believe this is the last chapter for a long time, or at least a little while, that you can't use your calculators. We're going to be dealing with circles and trigonometry in this chapter. Circles and trigonometry. 71 through 74. Find the length of the arc of a circle with a radius of r and a central angle of 45. Now, who thinks they can tell me what an arc is in their own words? Right. It's just a portion of its circumference. Now, how many degrees are in a circle? Very good. Thank you. Now, there are two ways to do this. In my opinion, the easiest way to find the length of an arc is to just find a portion of the circumference. We know how to find the circumference of a circle, right? And then just multiply that by whatever your angle is over 360. That's the way I personally believe is the easiest way to solve these. Find the circumference and then multiply it by your degrees over 360 and you will have found the portion that you need. So, now because you will not be allowed to use a calculator, you may leave pi in it. You don't have to calculate pi in. But if you want to, you can just use 3.14 or you can use the pi button on these calculators if you want. So, r is 12. Sorry, I had a sneeze coming. Why did I put 12 in here? Radius is 12. I'm sorry. It's 2 pi r. The radius is 12. That's what I should have written. So 24 pi. 45 over 360. Does that reduce to what? I believe it's 1/8. So that's 24 pi over 8. How does that reduce? 3 pi. So the length of our arc is 3 pi inches. Or, like I said, if you don't like all that reducing stuff, then just put it in the calculator. Yes. Inches. I should. Probably not, just because I don't care that much, but technically it would be incomplete. Okay. This is section 4.1. We are in chapter 4. We're coming back to chapter 3 later in the year. This is chapter 4. So if you just wanted to punch it in the calculator, you could have just done 2 pi r times 45 over 360. And you should get like 9 point something or 10 point something. Yeah, which is the same as 3 pi. If you didn't want to do all that algebra reducing. It's up to you. They're the same answer. I'll accept either one. So what's the only thing? Somebody tell me how to set up number 73. 2 pi. Okay, Lazarus is going to do it. 2 pi times 8. Muy bien. There you go. Now you may notice the numbers for these are 71 and 73. That's because these are coming at the very end of the section. However, I thought they don't need anything in this section to answer these problems. You haven't really done anything new. All you had to know was the formula for a circumference. So I thought I'd put these in first. But these will actually be coming at the very end of your assignment today. Questions about how to do those? Alrighty. Well, we just talked about this. I guess I should have put this before. Length of an arc. Now, it says you find the length of an arc just by taking r times theta. Well, that doesn't seem right. You can't just take r and times by 45. That would, like on the first one, that would have been wrong. When they say theta, their theta whenever you're finding a length, let me back up. When you are on your calculators, when you put in, if you've ever done any trig before, which I know you all have back in geometry, you probably heard your teachers be like, make sure you're in degree mode, right? So you're putting in like sine 45, all that stuff. Well, why do you think radian mode even exists? Why do we need radian mode? Do I have a theory? Radians are how you convert circular measure into linear distance. For instance, who knows anything in here about cars? Glenn, okay. What's the average wheel size? Is that a diameter radius? Let's go higher. What is that? Is that the radius? Is that the diameter? Is that the circumference? I bet that's the diameter. Let's assume it's the diameter. Okay, very good. Now, let's say you get in your 31-inch wheels car, and let's say the only thing you had in your car was number of times your wheel went around, revolutions. So you get in your car, you drive to school, and it says you made 727 revolutions. Well, there's 360 degrees in a circle. We went 727 times. But how do you convert? How do you convert that circular distance, 727 revolutions, into a linear distance? Well, the way to do it without thinking about radians is how we just did those last few problems. Just take however many degrees you did, so that'd be 727 times one full revolution, which is 360, and you have some huge degree number, and you take the circumference of your tire times that ginormous number over 360. What radians do, and the reason I'm going to teach you all about them today and throughout this chapter, is that by converting your degrees, 360 degrees, into radians, you've already converted like a circular distance, like degrees, into a linear distance, which is why, technically speaking, to solve those last few problems, all you really needed to do was take your radius and multiply it by your angle. But you just need to remember that your angle would need to be converted into radians, which is what I'm going to show you how to do now. To convert, I hope that's the next slide. Yes, it is. No, it's not. We'll come back to that. Okay. The measure of an angle is given. Come on. That's easy stuff. We haven't even done this yet. I thought we... Hold on. Here we go. We're going to start with these. Convert each angle into radians. Now, let me ask you this. Let's go back to our circle thing. Somebody tell me what the formula for the circumference was again. 2 pi r. All right. Very good. Now, circumference, right? 2 pi is one revolution around a circle in radians. 2 pi, here's the big equality. And this is what you need to have somewhere nice and big in your notes. 2 pi equals 360 degrees. 360 is degrees, 2 pi is radians. Bless you. 360 is degrees, 2 pi is radians. With that fact alone, you can set up proportions to solve all these. Now, so here's what I mean by that. If you were to convert 45 degrees into radians, you all could probably logically just be like, well, wouldn't that just be a proportion? 45 over 360 equals x over 2 pi. I'm positive most of you could probably logic that proportion. But there's certain parts of this, I mean, what would you always do now? You'd always cross multiply, blah, blah, blah. Here's a simplified version of that exact same proportion. When you are converting degrees into radians, all you have to do is multiply by pi over 180. That's the simplest way to do it. Multiply by pi over 180. So that'll be 45 pi over 180. What's 45 over 180 reduced to? 1/4. That's right. So pi over 4 is the radian equivalent of 45 degrees. Pi over 4 is the radian equivalent of 45 degrees. Let's try another one. Let's try 300 degrees times pi over 180. So that's 300 pi over 180. Let's see, you can divide top and bottom by 60 and get 5/3 pi. And that is the radian equivalent of 300 degrees. I would, yes. Leave your pi's in there. Don't bother finding a decimal. The negative doesn't change anything. You still multiply by pi over 180. Somebody do your reduction. Let me know what you get. It'll be a negative. You're allowed to use calculators on this. I mean, you'll have calculators. That's what I was going for. Negative 5/4 pi. Negative 5/4 pi. Are there questions about where we are getting these? Now, to connect the two things that we've done already, if we were to go back to this first slide, if we had converted this into radians first, now, we just did negative 225, and wasn't it negative 5 pi over 4? So positive 225 would be positive 5 pi over 4. Now, what was that formula that it gave us on the very next slide? R theta. So what if we did it now? What if we just took R times theta? Somebody punched that into your calculator, and, well, actually, we never finished this one, did we? Who has, raise your hand if you have a calculator in front of you. Jordan, you punch in this one, and Jenny, you punch in this one. And then both of you blurt out what you get. Which one? This one right here? So that'd be 10 pi, 31.4-ish. Let me know what you get, Jordan. That's fine. Perfect. That's what we got for the other one. What? Over here? 5 pi. We had just converted this one on the last slide, so I just kind of skipped that step. But as you can see, the way we were doing it, 2 pi r times the ratio of our circle that we're using, is the exact same thing as if you just converted that into a radian and multiplied that by your radius. You get the exact same thing. And that's what radians do. Radians convert angle measure into something linear, like 31.4 feet, which is what I should have labeled it, which is why I don't care. So that's kind of hopefully brings the whole thing together. Now, if we multiply by pi over 180 to get degrees, then to go the other way, all you do is flip that. Multiply by 180 over pi. Basically, whichever one you start with is going to be the one you're dividing by. If you start with degrees, you're dividing by 180. If you start with radians, you're dividing by pi. So, that's going to be 180 pi over 2 pi. What is that? Oh, pi. The pi's are going to cancel. 180 over 2, 90 degrees. Pi over 2 is the same as 90 degrees. Try 25 and 27 on your own. See if we get the same thing. Try 25 and 27 on your own. Just got a little chilly in here. Katie Beth, you found either of those? That's what I got. 210. And Blake, you found 27 for me? Not quite? I will wait. Yes, ma'am. Okay, that'll work. That is correct. Negative 540. Now you may be like, whoa, 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 that's greater than 360. Who cares? 2 pi is 1 revolution, and 3 pi is bigger than 2 pi, so it's obviously more than 1 revolution, so that's exactly correct. What's that? Where? Same thing. You always multiply by 180 over pi. So it would be negative 3 pi times 180, which would be negative 540 pi divided by pi to the pi to the 15. Now, there will be one today, just to be a jerk. I don't think I have one like that up here, though. Yes? What if the wheel had gone backwards? Okay. All right. Now, you know how some people just plug in pi and they get a decimal? So you could still have a radian without a pi in it. Let's say they say you have 10 radians. If they say it's radians, then you still do it the same way, even though there's no pi to cancel. You'll still multiply by 180 over pi. That'll be 1800 over pi, and you're going to have a decimal left. So what is 1800 divided by pi, someone? 10 radians, that's like 3 pi. It's probably going to be like 540. 572.9? Okay. There you go. Even if it doesn't have a pi on it, no big deal. Although, yeah, when there's no pi in it, the only thing that's going to be ugly is you're going to have a non-pretty number, like that ends in a 0 or something, because, you know, that you're dividing by a decimal. But it's no big deal. You still solve it the same way if it was a radian. Questions about anything on the board?
What's that called? What time is what?
You're just converting. You're converting radians to degrees and vice versa. He asked a good question. A very good question. He said, well, what is this called? Whenever you see the word convert in your directions, that's you hear me going one way or the other. Okay. Now we skipped a slide. Let's go back and hit it now. I think we skipped 2 slides. Okay. Find the radian measure. Find the radian measure, the central angle. Now, it's giving us the arc length and the radius. Now, this makes more sense now that you realize degrees, angles can come in radians. The beauty of that is, if I had said, hey, what's the measure of the angle? If you have an arc length of 40 and a radius of 10, you guys might have freaked out a little bit because you've been like, well, those are both lengths. How am I going to find a degree measurement? But now that you know, hey, I can just find a number and that's going to be our radian, it's just as easy as it looks. The arc was 40, the radius was 10, divide by 10, and 4 radians is your theta. I would like you today to write radians on these problems. Now, who wants to overachieve and find how many degrees that is? For all those curious people in the crowd. What is 4 radians in terms of degrees? We just did it the last slide. Times 180 over pi. You can do it. I believe in you. What would that be as degrees? What was it? If I had to guess, pi is 3.14, and that's half a revolution. I'm guessing it's in the 220, 230 range. Woo! Nailed it. Very good. So, even though they're asking you for an angle, the fact that you just get a number is not the problem. Now, I don't think it asks for it in any terms of radians or degrees. So, please make a note somewhere on your notes. Just to get in the hang of viewing angles in 2 different ways, I want you to find both for problems 8 through 12 in your homework. 4 radians. Yes, because here's why. Here's why. If you don't get in the hang of looking at both of those as angle measures, think back to geometry when your teacher was like, you have a 30, 60, 90 right triangle. You guys are like, ooh, I know what to do with this. But on your test for chapter 4, you're going to have a triangle with the angle measures being pi over 2, pi over 6, and pi over 4. And you're going to need to know, hey, that's just the same as degrees. I'm going to handle it the exact same way. It's just in degrees. It's just in radians. That's all. Is there a question? Oh, actually.
Yeah, where did you get his?
Oh, they converted this into a degree, just like we did the last slide, times 180 over 5. Was there another question? What? Oh, Gianna, were you going to take your test today? Okay, just kidding. You can take it tomorrow. Oh, right. Right. Don't forget to remind me. Okay, now, what were you asking, Sarah? Yeah, there you go. What's the trick to number 11? Why is that one going to be just ever so slightly harder? Yeah, you have to convert it. How many centimeters are in a meter? 100. So what you really want to do is just convert it to 100 centimeters first, or you could have converted the second one to 4 meters. It doesn't really matter. And then solve it the same way. 9 or 11, does somebody want to see one of those work? Sure, let's do number 9. S, let me change colors. S equals R theta, divide. 8 divided by 6 reduces to 4/3. If you're going to leave it like that, I want you to put radians. Radians. S equals R theta. That was the technical formula for it. Now, remember, I also want it in degrees, so we're going to take 4/3 times 180 over pi. So somebody punch that into a calculator. Did you remember to divide it by 3 pi? It should be like 80 something. 76, yeah. Did you remember to do 720 divided by 3 pi? You're dividing it by 3 and pi. Well, you did. 76 is right. Over pi? Yeah, same difference. Yeah. The people who are wrong, they only did the 3 or the pi. They didn't do both of them. Questions about that one? I think we've only got 2 slides left. No, I take that back. Maybe 3. Oh, except this should be... Yes, ma'am. Oh. Hopefully... Dang it. Sam. Sam, what is an acute angle? Very good. Which of these is an acute angle? Very good. What's an obtuse angle? Very good. What would number 5 be? Ooh. Easy. That's right, which is a what angle? Yes, it's a straight angle. Very good. If they give you a radian, just convert it to degrees. You should get this one as 180 degrees, which is a straight angle. Acute less than 90, obtuse greater than 90, right is 90, and straight is 180. So, those should be really, really straightforward questions for you when you get to them. You just may have to convert. I don't know why they asked you to do that before they asked you to convert. That's why I did those out of order. But now you know. Okay, convert each degrees to radians. Didn't we just do this? Oh, the difference is these are not like the nice ones. They're not the 135, the 210s. So like 18 is a tad uglier. So times pi over 180. Actually, this will reduce kind of nicely. What does 18 over 180 reduce to? That's right, 0.1, or I prefer fractions. So pi over 10. These are going to work the exact same as the previous slide. I'm not entirely sure why they got their own. Oh, that's why. Right. Yes, put it in. Read the directions, Crawford. What is pi over 10 in your calculator? To 2 decimal places. Yeah. I'm really just disappointed in myself that I had that. Okay. Very good. So anyway, solve those, take it to 2 decimal places. Last slide. And that... I'm sorry. So these convert to degrees. Again, round to do decimal places. Oh, these are the ones I was telling you. So we do have a slide for them, where they may not put pi in there every time. So we'll do 37 and 39 together. Getting this to degrees, so times 180 over pi. That's 180 pi over 13 pi. Pi's cancel. I have no idea what 180 over 13 reduces to. 1 point something. Just kidding. 13.8 degrees. Excellent. And 39, negative 4.8 times 180. No, this is degrees. You're converting them into degrees. See, it started in radians. You do not know. Only put the pi sign if you actually have a pi left in the equation. If you don't ever just throw one in there. Okay, so negative 4.8 times 180 divided by pi as a decimal, please. 0.0? Oh. 0.019, so 0.02 degrees. Muy bien. Questions? Are there questions? Good. Maybe you do have like an hour.